Hello everybody and welcome back to another video. Today we're going to be talking about autocorrelated areas as part of chapter 13.7, and we're going to pair that with another Pearson question and an Excel tutorial. Okay, so what are autocorrelated areas? Essentially, it is a relationship between two residuals from one period to the other, or from one period to another period, let's say. So essentially what this means is that there is something in your unexplained, okay? You have an explained portion that's right, your SSR that is explained by the regression, and your SSE that is not explained by the regression, okay? And there's something in that not explained section, all right? A relationship between your residuals from one to another in another period that's affecting how the residuals deviate from each other, okay? So there's some relationship in your error terms that are affecting, sort of like a lag variable affects, sort of like you have a y lag variable affect the future value of your y, only this is in our error terms, okay? It's not being reported as a part of our function that we've created, part of our relationship, part of the formula that explains what we're trying to explain. It's not being reported, but it's happening amongst our residual errors, okay? So let's go over how you test for this. A little bit cut off there, but that's okay. We have our Durbin-Watson test, which is the residual in period t minus the residual in period t minus 1 squared all the way through the summation over the summation of e squared, the residual squared. Okay, so it seems a little complicated. I'll show you how to do that in Excel in just a moment. Let's continue. We have our Durbin-Watson scale. Okay, it goes from 0 to 4. We have two inconclusive ranges from dl to du and 4 minus du to 4 minus dl. These are not enough evidence to reject, not enough to say that we're right, inconclusive, may point to something, may not. We have our two rejection regions from 0 to dl to 4 minus dl to 4. Okay, these are either positive autocorrelation where rho is greater than 0, or negative autocorrelation where rho is less than 0, okay? And so let's get to our Pearson question. So as you can see, I've done the first regression, and as far as I'm concerned, there may be some rounding differences between Pearson and Excel, okay? Because let me show you exactly what I'm talking about here. So I have our data sheet here. Let me just rename this really quick. I have our data sheet here, and there seems to be, I seem to have erased the first number. What was it? 14744. Let's put that back in. 14744. Okay, great. So we have our data sheet here, okay? And I have created the lag here. I've removed the last row because of the space where there's nothing occupied here, because right, if you create a lag, for example, let's just do this just to show you an example. Here we go. So say we have these 12 observations and we have some data between them. All right, so if I want to create a lag here, I'm going to put these down one. Okay, and so the first row is going to be not used. We're going to skip over the first one and start our observation from 2, our regression from 2, and we're not going to include the last row. So basically what I've done here already before you guys before I got on the video is I just edited it down like that. So that's why you see it. Anyways, so I've ran the regression, and as you can see, I have the values that are on Pearson, but there seems to be some weird rounding errors, as here I obtained, with a 0.02, but they're right on the dot, which is odd, yeah. This seemed to round fine. This seemed to round by 1 and some change there. And again, this seemed to be fine. So there's some weird, we may want to talk to your professor about that, because there's some weird rounding going on with Pearson, okay? That's creating some really minor problems, unless there's something wrong, but I don't think there's anything wrong. and from my memory, there seems to be sometimes some problems with the Pearson system. Okay, so let's just assume that this is okay. We have our regression here, okay, and you guys should know how to do regressions on Excel by now. You just go to data analysis, regression, you enter in your y's and x's, and you should be good to go. Okay, so it wants us to test for positive autocorrelation. Okay, so we're going to choose the correct null hypothesis, which is obviously positive rho is going to be greater than 0, and that's pretty obvious. Hopefully that doesn't need much explaining. So let's continue. Now it wants us to find our lower and upper Durbin-Watson stats, okay, with alpha over 5. And so when you're doing the Durbin-Watson, it's as simple as, you don't know if it loads up here. So we have our k being our variables, okay, in this case we have beta 1, beta 2, and the lag variable, so that's 3 for k, okay, and then we have our alpha, which is this Durbin-Watson test is only for alpha, alpha 5, right, 5% alpha, in which case if it was a different alpha, they would have given us a different Durbin-Watson table, okay, and there are no degrees of freedom, okay. So we have an n equal to, let's see, does it not tell us? Let's check our regression then. N equal to 27, okay, so we go down to 27, we'll go across to k equals 3 because we have 3 variables, and we have a Durbin-Watson lower stat of 1.16 and an upper stat of 1.65, so let's enter those, 6 and 1.65, great. So now we're going to determine our Durbin-Watson statistic, and this is a little annoying, so bear with me. So we're going to go back here to our formula. This is what we're going to create. Okay, we have E in the first period minus E t minus 1 period. Okay, the residual in the first period minus the residual in the t minus 1 period, or the t period, I should say, squared, summed over all the residual squared. Okay, so I'll show you exactly how to do this. So we have our residuals here. Okay, now we're going to build a new y and some new plots, some new cells here from this residual. So we're going to have our residual squared, which is going to be the denominator portion of our Durbin-Watson test. So let's go ahead and do that. And we're going to have this equal to residual squared, okay, and we're going to pull this right down and get rid of these excess because that's below our table. All right, and now we're going to have the residual. What should we call this? We'll just call it residual E minus E, okay, just to keep things a little more organized, okay. And so we're going to have the residual in the second period, right? So it's ET minus 1. So we can't start with 1 because there's nothing behind it to subtract. So we're going to start with 2 minus, so this, we're going to start with this as period T minus T minus 1. Okay, and we'll just put that in brackets just because, and we're going to square that as well. Okay, so now we have the first value of this table squared, but it wants us to do the summation of all values. So we're going to have to go down the table, and we can just expand our Excel formula to fill everything out. Okay, and as you see, as we go down, Excel will just adjust. I'm sure you guys know this by now, but Excel will adjust, right? It'll keep going down and down as the formula is applied and doing one minus the other squared, you know, until it gets to the bottom, until we fill out all the rows. Okay, so now we're gonna sum both sides. Let me just put this in yellow so we can see a little better. Maybe we'll put some borders so it looks a little cleaner. All right, so we do this by going equal sum. Okay, you click on the sum function, you highlight the array, and it'll add those all up together. So we have our e squared, our residual squared sum here, and then we have our residual of t minus residual in the t minus 1 period squared over here. So let's sum those up. Awesome. And now we're going to do, and now it's as simple as putting one over the other. So we'll call this our d stat, okay, over here, we'll have this equal to the sum of the difference of residuals, okay, the difference of residuals is what I actually should have called it, over the residual squared. And there you go. And I believe it wants 3 decimal places, so let's round this down. Okay, great. And we'll just copy and drop that in over there. So it's asking us now, do we reject, do we not reject? We know that this is greater than our lower and upper, but we need to know where it falls on the whole scale. So let's go back to our scale here. So we know these two, we know where our stat we know lies somewhere here. So we just need to find these other two, okay? We need to find the other two on the scale and see where our stat, our 1.758. So let's do that in Excel. How about that? Okay. So let's start with our low. So we'll have a 0, then we'll have a 1.16, and then 1.65 is the upper. And then we'll have 2 in the middle. Okay, now we're going to do, because it ends at 4, so we have 2 more here, right? This is what we're going to find. We have 4 at the edge, and then this is going to equal 4 minus here, okay, 2.35. And I just realized that this actually falls over here. So I don't know why for a second I thought 1.78 was going to be greater than 2, but let me show you at the same time, because you might get a question that will require you to do this. And then we'll do 4 minus the upper. Okay, there you go. So this is our completed Durbin-Watson scale. It looks a little funny on Excel, but just so we can get a good idea. So right now our observation of 1.758, where does that fall? Right, it'll fall somewhere in between the 1.65 and 2, obviously. Okay, so maybe we'll highlight these and merge them together. Okay, 1.758. There you go. Was that right? Did I already forget the number? No. Okay, awesome. So within this region, we're going to say there's no evidence of autocorrelation. Okay, so let's go back to our graph here. So we're over here. We're in between right here. And so we know for here, there's no evidence of autocorrelation. If we were in between our DL and DU, which in this case is 1.16 to 1.65, even there we wouldn't say there's evidence of autocorrelation. We'll just say the test is inconclusive. The same goes for this region right here. Okay, so it's as easy as that. So we can go and now say that there's no evidence of autocorrelation in our Pearson, which would be the test shows evidence positive, negative, uncertain, no, shows no evidence of autocorrelation. I mean, I had to read the list to find it. Okay, so let's go ahead and check that. Awesome. And so that's the basics of autocorrelation. Again, I always have been bothered by this little rounding. Hopefully someone can one day tell me why Pearson seems to round differently. On sometimes I'll get them all right, and sometimes it'll be just these minute small errors. So especially if you take the quizzes with Pearson and you get a mistake, then you should contact your professor. Don't let them take away those extra grades from you. Make sure that at least maybe there's something wrong, but I think you guys will find the same thing when you do it. Okay, so that about rounds up our video. If you have any questions, drop a comment and I'll try to get to them. And for now, thanks for watching.